As you can see, here is my A staff or AO2 that I implemented. Give it a quick run to show it works. Yeah, nice and quick, gets the shortest route. Then here is my genetic algorithm, which is what I decided to do for task 3. As you can see, also nice and quickly it finds a thing. So how this works is first it just deals with the map data and gets it all nice and set up and whatnot, and it sets the chromosome size, the population size, the mutation probability, and the max loops, and sets up some other variables, and then creates a new generation of chromosome. Then it starts the training loop here, so everything inside from this point onwards is in the training loop. So it checks if any of the chromosomes can reach the endpoint by basically acting out their instructions and checking if it has reached the end or not. If it has, it breaks out of the training loop, and that chromosome's path becomes the route that's taken. If not, then it just keeps updating the position. It does this for each of the directions quite a lot there. Then it calculates the chromosome's fitness based off how close it gets to the finishing point. Then after this, it calculates the total fitness. Next, parents are selected for breeding. The higher their fitness, the higher chance they have of being selected, as I use the roulette wheel method for selecting parents. Then the parents run through the crossover operation to see if their children will cross over data or not, to share data. It's about a 70% chance this happens. At least that's what I've got it set to at the minute. Then after that's happened, there's a chance for all the offspring to have one of their bits mutate and flip. After that's happened, the previous generation is replaced by the new generation, and we check to see if the max learning loops have been reached. This is just a fail-safe in case the start point and the end point are blocked by walls, so it doesn't just get stuck in an infinite loop. And then after it breaks out, it then just outputs the results. Right, the A-star algorithm. So the bit I modified was here at the start. I changed this over so it accepts map data, and I made it slightly easy, even though it's hard coded, and I tried to make it easy for whoever has to input it. Then let's go all the way down here. The other bit I modified here as well. I have just made it so rather than randomly generating the map and then routing across the randomly generated map, instead it takes in the map data it is and then like fix the output a bit. Because it was a bit broken when I changed the map across. So the way it works, it comes down here, it runs pathfinding, and then that brings us up to the main pathfinding function. So it just does some initial setup, like resetting the node map and adding the starting point to the open array, and then it actually starts the algorithm. So it gets the current node from the list of open nodes, and then it adds that to the closed list and removes it from the open one because it's now been gone to, because obviously we're starting there. Whichever one it moves to, it moves to a closed one so it doesn't move back on itself. When it moves to a closed one, it sets a pointer so we can navigate back on when we find the endpoint. Then it checks if it's finished or not so it can break out. And when it checks for the finish, it actually maps the path here by following it back here. So that's done within the loop. Then it generates new child nodes in all possible directions for new moves. Now it's moved further, it has more options of where it can move to. Of course, as it does this, it needs to also update the priorities. So based off like how far they are to the ends, or new moves it can take, so it updates the cost of each node here, and it finds to see if there's a better one or not, and then it just clears it up, and it literally just repeats this loop until it breaks out. So this one's a lot simpler than the other one. Yeah, and that's it.